Okay, welcome to the lecture today. We're going to talk about in and out problems. This is a standard question that usually appears on every AP test. I'm going to try to make this video as exciting as possible, but it is 6:30 in the morning, so that might be kind of difficult. But here we go. Brittany, take your sweet tea off your desk. Moises, quit terrorizing Harley. And Viraj, wake up. Okay, so just make sure you're paying attention. And now if I ever want to reuse this video, people are going to have no idea who those people even are. But that's the beauty of our class. We have inside jokes that nobody else knows about. Okay, so here we go. The first question is from 2015. The premise of these problems is that typically they always give you two rates. Okay, so the first thing you're going to want to make sure of is that you understand what's being given to you in these questions. The very first thing it says is the rate at which rainwater flows into a pipe is modeled by the function r, where r of t is equal to this. So the very first thing that everybody should do right now is plug this into y equals on your calculator. Okay, so if somebody wants to pause the video so that everyone can get that done, let's go ahead and do that, but let's make sure that we put that in our calculator. Okay, it says that the pipe is partially blocked, allowing water to drain out the other end at a rate. So again, there's your second rate. You have a rate that goes in and a rate that goes out. And this rate is modeled by d of t is equal to this. And so you want to make sure that this gets put into your calculator as well. And then it says there are 30 cubic feet of water in the pipe at t equals to 0. And that's probably some information that we're going to use at some point. Okay, part A, how many cubic feet of rainwater flow into the pipe during the 8-hour time interval? How many cubic feet of rainwater? That is an amount. Let's write it very carefully. Very terrible handwriting. Amount. If I want an amount and I'm given a rate, class, say it with me. Yes, integrate. Very good. I could hear you all the way from home. Okay, so we want to integrate the rate at which water is flowing into the pipe here. So for part A, that's going to be an integral of r of t dt. The interval is given to us in the question. It says from 0 to 8, and this is going to give us the amount of water that went into the pipe during that 8-hour time interval. And so if you just use your calculator to figure out what the answer is, then you're going to get 76.570. All right, very good. Part B says, is the amount of water in the pipe increasing or decreasing at time t equals to 3 hours? Give a reason for your answer. Well, that's going to depend on the rates. If the rate at which water is coming into the pipe is bigger or smaller than the rate at which water is going out of the pipe. So what I want to figure out is what is the rate of water going into the pipe at t equals to 3. And that's not r prime of 3. It's r of 3 because remember, r of t was already a rate. Okay, so r of 3, if I type that into the calculator just real quick, okay, that's going to give me 5.0863. So 5.0863. And this is why it's a good reason to type it into your calculator in y equals, because at some point you're going to have to do multiple things with these functions. Okay, so that way you don't have to retype it a million times. Okay, and then if I find d of 3, then what do we have? I'll just type that in real quick. I just used the variables function on the calculator. I got 5.4. Okay, so you can clearly see that the rate at which water is leaving the pipe is bigger than the rate at which it's coming in. And so what that means is that the amount, please excuse the terrible handwriting. It's very tough to write on this little tablet thing that I'm using. The amount of water in the pipe will be decreasing. So will be decreasing. I'm not really sure that that's how we necessarily want to word that. Probably just want to say is decreasing at t equals to 3 since r of 3 is less than d of 3. So the tricky part on that question is to realize, okay, I need to use r of t and d of t because those are the rates, and that's what's going to tell me if the water is increasing or decreasing at any particular time. Okay, part C, it says, at what time is the amount of water in the pipe at a minimum? So this is a very standard question. The first thing that you're going to want to do is write an expression for the amount of water in the pipe at any given time t. Okay, well, anytime I want to write an amount and I'm given a rate, I know that I have to integrate. So I'm going to have to integrate from 0 to t, because I don't know what t is. T could be anything from 0 to 8. So I just integrate from 0 to t. And then I want to integrate the rate at which water is leaving minus the rate at which water is, R is the rate at which water is coming into the pipe, and then subtract the rate at which the water is leaving. So R of x minus d of x. And now is where my initial value of water comes into play. So remember, they gave you this initial value. That's going to be the thing that you forget the most. Okay, so you just have to be very careful to put in that initial value. Okay, and anytime I want to find a minimum, okay, that's going to require the derivative. So remember, the first semester we talked almost exclusively about how do we find maximums and minimums. That's the derivative. So I have to take the derivative of this function that I just wrote. Okay, well, the derivative of 30 is just 0. And the derivative of that integral, I just take the t and I plug it into the x's. So that's going to be r of t minus d of t. And to find the maximum or the critical point, sorry, not the maximum, the minimum, we want to find the critical point, which means I have to set the derivative equal to 0. Okay, and what that gives me is that r of t is equal to d of t, is whenever the critical point is going to happen. Okay, so in order to solve that equation, I have to use my calculator. So you need to go to the graph. You probably want to change your window range to 0 to 8 on the x-axis, and then see if you can find the intersection point. Okay, so the intersection points are going to be t is equal to 0, and then also 3.271658. So 3.271658. Okay, so you might want to just pause the video just to make sure that you can get those values. Okay, because you want to make sure that you're doing this along with me and that you can follow what's going on. Okay, at this point, we want to find the minimum, and so we need to set up a candidates test. My candidates for amount, for minimum amount, are going to be the endpoints, which are 0 and 8, and this critical point, which is 3.271658. And probably what you want to do is in your calculator, you want to store this as some value A. Okay, that way you don't have to keep retyping it a million times. Okay, well, what am I going to plug back into to get the amount? I'm obviously going to plug back into A of t, which was my equation right here. Okay, so A of 0, if I plug in 0 for t, that's just going to cancel out this whole integral because the bounds will be the same. They'll both be 0. And so the initial amount in the pipe was 30. Okay, at the critical point, I have to actually type that in my calculator, so I would type in 30 plus the integral from 0 to a, in this case, of y1 minus y2 is how I did it in my calculator. Okay, and so what I'm going to get there is I'm going to get 27.9645. 9645. Okay, so there's the value for the amount of water in the pipe at the critical point. And at the other endpoint, at t equals to 8, I would do the same thing and just replace the a with 8. And then I'm going to get for the value 48.5436. Okay, so please make sure that you're following along in your own calculator. I know I'm going kind of fast, so you guys might need to maybe pause the video a couple times just to make sure that you're getting the same values as me. So somebody take charge of that. Please. Okay, so if we look at our candidates test, obviously the minimum value is the 27.9645. And so the question is asking at what time. We're just going to say a sentence that kind of covers everything. So the minimum amount of water in the pipe is 27.9645, and that's liters, at 3.2716 hours. Okay, so that's how we answer part C. Okay, part D says the pipe can hold 50 cubic feet of water before overflowing. For T greater than 8, water continues to flow into and out of the pipe at the given rates until the pipe begins to overflow. Write, but do not solve, so we don't actually have to solve the equation we're about to write, that involves one or more integrals that gives the time W when the pipe will begin to overflow. Okay, so we know that it begins to overflow at 50. So when A of T is equal to 50, that's no good. Okay, no good at all. So what we want to do is we want to just basically use our equation from part C that we already wrote. We want to substitute in 50 for for A of T, and for T, we're going to want to substitute in W because that's when the pipe will begin to overflow. Okay, so I just take that same equation that I already wrote, I substitute in 50 for A of T, and then I have 30 plus the integral from 0 to W of R of X minus D of X dx, and that's the equation right there. I just plug in the amount when it's going to overflow, which is 50, and the time at which it's going to overflow, W, and that's the equation that would give me the time at which the pipe will begin to overflow. Okay, number 2, I'm going to go ahead and let you pause the video so that you guys can plug in the equations to your calculator, and I'm going to do the same thing as well. So I'm going to pause it real quick. Okay, now that hopefully we have all of that plugged in, okay, plugging in that g of t function, we can start this problem. So it says on a certain workday, the rate, so please again make sure that you understand they are giving you a rate at which unprocessed gravel arrives at a gravel processing plant. So this is like your N rate, if you want to think about it like that, is modeled by g of t. At the beginning of the workday, the plant has 500 tons of unprocessed gravel. We're going to use that information at some point. During the hours of operation, the plant processes the plane. Okay, that's a typo. That should not say plane. Haha, Mr. Castle doesn't know how to type or read or both. The plant, well, now it says planet. Okay, great. Well, you understand what I'm trying to say. The plant processes gravel at a constant rate of 100 tons per hour. So that is my out rate. Okay, we're processing gravel at a rate of 100 tons per hour. Okay, part A, find g prime of 5. That is maybe the easiest question on the entire planet. Because we have a calculator, we can just type in how to get the derivative of g at 5. So that's using the math 8 function on your calculator. Okay, so for part A here, g prime of 5, you don't even really have to write how you're going to do that in the calculator. You just have to do it and then get the answer. So it's negative 24.588. And now it wants to interpret your answer in the context of the problem. So that's maybe a little more challenging. Okay, so remember that G was a rate. So we want to say the rate at which gravel, again, sorry for the terrible handwriting, the rate at which gravel arrives at the plant is decreasing. So think for a second, why is it decreasing? Okay, it's because the rate of this, or the value of this derivative is negative, so that's why the rate is decreasing. And we want to say at a rate of 24.588, we need to put an appropriate unit, so that's going to be tons per hour per hour. Okay, because g of t was already measured in tons per hour, So when we take the derivative, another per hour gets added on, and then we need to make sure that we say at time t is equal to 5. Okay. Okay, so here we go. Part B, it says find the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this work day. So we're asked for an amount. So there's our amount that we're asked to find. And we want to find the amount that arrives at the plant during the hours of operation. So say it again with me. If we want to find an amount and we're given a rate, we should... Yes, very good. Integrate. Okay, so we're going to integrate over the hours of operation. Sorry that my handwriting is going to get even worse here because now I'm having to use the mouse. My little pen has died, so that's not very good. Okay, so the integral from 0 to 8, the rate at which gravel arrives is given by g of t. So this is going to be g of t. This is really quite awful. I'm having to use a mouse here. Okay. So the integral from 0 to 8 of g of t dt. I know you guys are laughing at this, and this is pretty, I would say, funny. Just looking at what is written on the board. Kind of looks like a kindergartner wrote this. Okay, so if you type that in your calculator, you're going to get 825.551, which is really hard to draw with a mouse. Tons. Okay, and that's all you had to do on that question. That was actually worth 2 points. You got 1 point for the integral and then 1 point for the answer. So not a very hard 2 points to gain right there. Okay, part C is the amount of unprocessed gravel at the plant increasing or decreasing at time t equals to 5 hours, and then show the work that leads to your answers. So this is very similar to part B on the first question that we did. So the first thing we want to do is we want to compare the rates at which gravel is leaving and arriving at the plant. So the rate at which gravel is arriving at the plant at 5 hours is g of 5. Okay, so you just type that into your calculator. You can just use y1 of 5 on your calculator. And the answer should be about 98. So 98.1407 it looks like. Okay. And so the question is that bigger or smaller than the rate at which gravel leaves the plant, at which the gravel is processed? Well, if you read back to the question right back up here, it says that gravel is processed at a constant rate of 100 tons per hour. So this number is less than the rate at which gravel is processed. Okay, and so what that means is, hopefully you can understand, the amount of unprocessed gravel at the plant is decreasing because we are processing at a faster rate than gravel is arriving. So you would want to say a sentence. I'm not going to do that because obviously I'm using a mouse here and it would just be completely ridiculous and terrible handwriting, but you guys get the idea. You would want to say something like, at time t equals to 5, the rate at which unprocessed gravel is arriving is less than the rate at which it is being processed, and so that means that the amount of unprocessed gravel at the plant is decreasing at time t equals to 5. And I'll give you the answers to these questions, like the scoring guidelines, so that you can see exactly what the College Board wrote in their answer. Okay, part D, we'll make this the last question since my little pen ran out, and then I can just give you the answers to the last one. You guys can try that one on your own and see how you do. Okay, so part D, what is the maximum amount of unprocessed gravel at the plant during the hours of operation on this work day? So that's very similar to part C on the last question. The first thing we want to do is we want to write an expression for the amount of gravel at any time t. Okay, so you have to remember your initial amount. Remember, I told you we were going to use this information at some point. It didn't come until part D, but we did use it. And so here we go. We're going to have our initial amount, okay, plus an integral from 0 to t, okay, and then we're going to take the rate at which gravel arrives, which was given by g of x, okay, and subtract the rate at which gravel is processed, which is 100. Okay, again, just absolutely terrible handwriting, so hopefully you can understand what's going on. And like I said, I'll give you the answers so that you can kind of see exactly what's happening. Okay, so we want to check the endpoints, which are 0 and 8, and we also want to check the critical point. To get the critical point, we need to take the derivative of this thing that we just wrote. So a prime of t is going to equal, in this case, g of t minus 100. Okay, so again, remember the derivative of 500 is 0. And then to take the derivative of this integral, we just take t and plug it in for the x. And if we set this equal to 0, then what we're going to get is that the critical point happens whenever g of t is equal to 100. Okay, and so that has to be solved in the calculator. You're not going to be able to solve that by hand, and so you have to solve it in the calculator. Make g of t your y1, which it should already be your y1. Make 100 your y2, and then you would just find the intersection. Make sure that when you do your window range that you can see 100 on the screen, so that means you're going to want that to be in the range of your y min and y max. Okay, what you should get when you do that is t is equal to 4.92348. So 4.92348. So again, make sure that you're pausing the video and allowing everybody to make sure that you're getting the same thing when you do that in the calculator. Okay, so now that we have our critical point, we want to check that critical point in our function a of t along with the endpoints, which were 0 and 8. Okay, and I'm just going to kind of audibly say this, and then I'll give you the answers because, like I said, I can't type because I have a mouse, and that's not a very good situation. So if you check the endpoints at t equals to 0, a of t is going to be 500. So we kind of already knew that, but just checking that, t equals 0 gives a of t equal to 500. And then at the critical point, the amount of gravel is 635.3761. So make sure that you can type that in and get that. So that was 635.3761. Okay, that was for the critical point, t equals to 4.92348. And then at the other endpoint, again, you're using your calculator to find these values. So you're plugging into this a of t function that you actually wrote down. At t equals to 8, you're going to get 525 and some change, 55.5510. Golly, that's terrible. Okay, 5510. So you can clearly see that the maximum amount of unprocessed gravel at the plant is 635.3761. You would just want to write a short, one-line sentence that says that, and then you would be done with this question. Okay, so make sure you know how to do these. There's probably going to be one of these on your AP exam. You can probably expect it to be either number 1 or number 2. These are usually calculator active problems. I have seen a couple that are non-calculator, but for the most part, they make these calculator active. So usually your 2 calculator active questions will be, kind of one of the following questions, either an in and out problem, an area and volume question, or a particle motion problem where you have to do some things with PVA. So that's kind of what you can expect on your AP test in May. Hopefully this was helpful for you. Now you can go ahead and try the homework, and if you have questions, as always, please feel free to let me know. I hope you guys have a fantastic weekend. And Viraj, time to wake up. All right, see you later.